Our next talk is by Lawrence Harris, from Mondelez, who's going to be talking about particle-water interactions versus all processing. Lawrence.
Right. Afternoon, everybody. My name's Lawrence Harris. I work for Mondelez International. If you're not familiar with the company name, you might be more familiar with some of our brands and products that we produce. So the likes of Cadbury, Cadbury Dairy Milk, Milka, Toblerone, snack foods is essentially where we're at. We are one of the world's largest producers of snack foods, ranging from chocolate to biscuits to crackers, and we still retain some work in beverages and cream cheeses as well. Being a snack company, we do operate quite heavily in the indulgent end of the spectrum. There's no escaping the fact that we do produce very large volumes of chocolates, biscuits, all the delicious, lovely things that I'm sure have been getting us through the last 18 months of pandemic or so. We do operate down at the more wholesome end of the spectrum as well. So if we look at things like our biscuit business, crackers, Belvita, Triscuit, if you're familiar with that as well. So we do operate across the spectrum of the indulgent to the more wholesome. And the wholesome end of our sort of product portfolio is a nice sort of segue into the particular challenge I'm going to talk through for the next sort of few minutes. What I haven't come with today is a very specific soft matter sort of problem, rather an application space or an application issue that we face. I think a solution to which could very well reside in some sort of soft matter-led thinking. There we go. So the context for my sort of next 10-15 minutes or so is around the reformulation and the re-engineering of established products which have a consumer expectation, and sort of the consumer eats a certain product, they expect it to taste and feel and deliver a certain experience. And when you want to engineer or reformulate those products towards a greater level of sustainability, you start to run into some challenges there, and you face an inherent tension that you have an established product which is based on essentially long-standing gold standard ingredients, sugar, milk powder, cocoa powder in the case of chocolate, and you're needing to substitute out a number of those things for ingredients which can bring sort of sustainability with them. And those tend to bring challenges whereby you still need to balance the cost of those ingredients. You still have to meet certain cost and margin criteria for this to be a commercially viable proposition, and you still need to meet the required level of consumer acceptance. There's no sense in reformulating to an elevated level of sustainability if it's never going to be, so if no one's going to purchase it, or even purchase it more than once, they're never going to see the light of day. So it's about how do you overcome those tensions of enhancing sustainability of your ingredient choices while still maintaining the functionality and cost and application requirements. So the particular case study I'm going to walk through here is the inclusion of increased amounts of fibre-rich ingredients, so dietary fibre-rich ingredients into low moisture comestible products. I'll skip forward a slide. So when I say low moisture comestible product, I'm talking about chocolate, essentially. So a quick whistle-stop tour of what chocolate is, at least from a structural sense. Chocolate is in essence a densely loaded suspension. You've got a very high volume, 60 to 70% roughly, of finely milled sugar, milk powder, cocoa powder predominantly, in a continuous phase of cocoa butter and a few other fats there as well. So structurally, chocolate has a lot in common with cement, paints and dyes, blood, funnily enough, cosmetics, and potentially slurries involved in battery production, as we heard about a few minutes ago. But chocolate is that densely loaded particle suspension. And when we look about the challenges of reformulating for sustainability, a significant area there is, well, how do you start to take out those particles, take out your sugar, milk powder, cocoa powder, and replace them with more sustainable alternatives? So it's about exchanging one family of particles for another, but then still achieving that functionality that you need. So hopefully that in a whistle-stop way, puts chocolate into a little bit of structural context if you've not come across it before. When we then talk about these fibre particles we want to start substituting in, What we're talking about here are typically bulk dietary fibre powders, typically derived from cereal, fruit and vegetable sources, either sort of primary production from various cereal crops. They can even come from recycled waste streams as well. Apple pomace, for example, the leftovers from apple juice extraction, the cores, the peels, etc., can be readily dried down and ground into bulk filler fibre powders, which can find certainly cost and certainly sustainability viable ingredient options there. So depending on your botanical source of your bulk fibre powders, depending on the level of kind of waste stream upcycling, these ingredients can offer some really compelling sustainability and cost advantages, but they do come with some significant application challenges there. The high insoluble fibre content can lead to product attributes typically described as rough, chalky, gritty, claggy, those sort of sensory descriptors you can sort of imagine if you had a great big mouthful of dietary fibre. And the particles themselves come with some challenging morphologies. You've no longer got nice, dense, crystalline sugar particles. You've got floppy, wobbly, rod and hairy and sort of finger-shaped fibre particles in your suspension as well. And if you're familiar with suspension rheology, one of the last things you can want sometimes is floppy, loose, rod-like particles when you want to have some nice predictable flow properties. The other issue with fibre particles is their response to moisture. This bit again. So I don't know if that's something I'm doing down at my end or if it's just a bad connection. These fibre particles like to interact with water. The big challenge you've got with chocolate, unlike something like cement or paint, for example, is that it will go into your mouth at some point, which is a lovely sort of moisture-rich environment. So we have chocolate, our densely loaded suspension. We've got fibre-rich particles, which, with a view to sustainability, we'd like to sub more of those in for some of our traditional ingredients. But then the challenge comes when you pop that in your mouth. So what we've got here is a sort of basic cartoon sort of walking us through what happens through consumption of a food, so for at least the chewing stage of consumption. So you begin with the initial bite. So you imagine biting down a lump of chocolate. You get that initial fracture into large pieces. As you go through the initial stages of chewing, it breaks down into ever smaller particles. You then start to get granulation as saliva starts to get introduced. Your small, broken down fragments of chocolate or whatever your food stuff is begin to kind of coalesce and stick together with saliva. And then you eventually get to bolus formation, that stage where you have at least it would feel like an homogeneous mass in your mouth just prior to swallowing. What it presented here looks like a lovely homogeneous, sort of nicely dispersed system. In reality, it's far from it. It's an incredibly messy and complex mass, as you can imagine if you were to chew and spit out some chocolate. But that's a very basic scheme of what goes on when you chew down and start to consume a piece of chocolate. And that's kind of where this challenge originates from. If we want to have a chocolate, for example, a low moisture food product containing high levels of fibre-rich ingredients, which is then going to have to be chewed to form a bolus, that bolus is what the consumer will experience. That's what will give them the experience which they're hoping to get or they expect to get from chocolate. Now, if you've inserted something like a high level of insoluble fibre particles, you've perturbed that system. Those fibre particles are going to begin to hydrate in situ. The hydration event which is taking place is going to be experienced one way or the other by the consumer. And then whatever stage of hydration it gets to immediately prior to swallowing it, those swollen water fibre particles are going to be contributing to the bulk properties of that bolus. And that is essentially what the consumer's experiencing and what they've parted with their money for and what we're trying to deliver to them in a more sustainable way. So it's that dynamic behaviour of insoluble fibre particles in mouth that is is the challenge here to high level adoption of these sorts of ingredients in low moisture products. So moving away from my little cartoon, this is what chocolate actually looks like. So on the left there we've got a micrograph of solid chocolate, I guess immediately prior to eating it. So what this is hopefully demonstrating here is you have the grey background there is your continuous fat phase. The blue markers there, or the blue dots there, are your dairy powders. The darker patches you can see, some of the little black fragments will be cocoa powder, and then the bright white regions will be your sugar crystals. So that's your densely loaded suspension. The micrograph on the right is an expectorated or spat out chocolate bolus. And what you see there, you've gone to a complete sort of inversion and change of it there. You now have essentially an aqueous continuous phase there. So the continuous black phase there is saliva, albeit saliva loaded with whatever sugars and other soluble materials have managed to get into your saliva. And what used to be your continuous fat phase in the chocolate is now discrete globules of sort of quite crudely emulsified fat. Still got some cocoa powder particles in there as well, picked out in green. So I guess this just kind of goes to demonstrate the complexities of what goes on in the mouth when you eat chocolate. You go from this relatively well-defined sort of static suspension system to this kind of now water-based bolus, in which your ingredients are continuously dissolving, hydrating, and developing these bolus characteristics that you really want to be delivering a pleasant sensory experience. So just to reiterate, linking back to these fibre particles, it's that dynamic nature, that dry, hard state of fibre particles when it goes into your mouth, how they evolve to their wet, soft state throughout the eat experience. Because by and large, these fibre powders are not intended to be consumed dry. So chocolate as a food, as a delivery mechanism, it's essentially putting an ingredient into your mouth which generally isn't intended to be consumed in that dry, non-hydrated form. The hydration job that your mouth is doing often leads to a number of challenges around oral processing, ones which we would like to overcome. So kind of bringing it all together, all I've got here is a very sort of simple cartoon. Again, just repeating that chocolate bolus on the left-hand side there, so your saliva continuous phase with your dispersed particles and your sort of semi-emulsified fat. I won't pretend that chocolate boluses, boli, are particularly well understood and characterised. There's still quite a long way to go to fully characterise and really understand how the various properties do drive sensory experiences. But if we take that at least as a baseline, we know that today, if that structure is generated in your mouth, it feels like chocolate. When we insert these fibre particles, that's when we perturb that system. That's when we have these dry, hard particles at the point of going in your mouth, evolving to soft, wet particles as they hydrate. How are those influencing the bulk properties of the bolus? And how do those bulk properties of the bolus deliver certain sensory properties that we either want to maintain, enhance, or typically avoid? So those chalky, dry, gritty, claggy descriptors I used earlier to talk about high fibre products in general, they're the sensory properties we would like to be able to modulate, ideally mask, remove altogether. So there's the challenge or the question around how can that hydration, the swelling, the softening, that process of in-mouth hydration and change of state of those particles be better understood, modelled, and then related to bolus and sensory properties. So this whole area of oral processing and understanding the properties of your bolus, the journey of how that bolus is created in mouth and link it to sensory, it's by no means a new topic. It's certainly, in the grand scheme of things, an emerging topic. I've cited here just a cherry-picked a bit of data from a couple of publications. The one on the right there is from Crop and a group at Leeds University. So that there is just demonstrating some very, very strong correlations there between bulk rheological and tribological measurements of sort of prepared hydrogels, and showing how those can be correlated very strongly with sensory descriptors across the top. So kind of showing that it is eminently doable to correlate mechanical and physical properties of foodstuffs and boluses to sensory. The picture on the left there is from Shewan at Queensland University. That's a summary of their work whereby they were engineering gel particles to specific size and modulus, suspending them in an aqueous phase to form like a beverage type system. And there, as they were modifying the modulus of those gel particles, the point at which panelists would perceive those particles and therefore start to describe this beverage system as being particle containing, rough or gritty or smooth, could be moved around. So again, just an example whereby understanding the mechanical properties of the particles in your suspension system, being able to tune their mechanical properties, can have a meaningful impact on whether they are experienced sensorially. The challenge with not necessarily these studies, but this area in general is when you look at work done to characterise particles and suspension-style food systems, they tend to fall into a couple of different categories. One is where they are moisture-rich environments, salad dressings, beverages, yogurt. So where a fibre particle may be present, they're present in a already hydrated, at least partially hydrated state when they go into your mouth. So you're not experiencing that in situ hydration and transition. Or where studies are conducted, the particles of interest have been engineered to a particular sort of mechanical state and then consumed and then assessed for sensory. There's not as big a body of work done around the dynamic nature of things, the actual in situ hydration and change from soft to wet to hard to dry. So for me, for my application, for the ingredients where we would like to make greater use of, that's where we see a significant challenge, that sort of dynamic as opposed to a static system for particle hydration and evolution of its mechanical properties, the impact it has on the bolus, and then the sensory perception of that bolus. So just as a closing point, I've laboured quite heavily on chocolate, given that's the world that I come from. But really, this is around low moisture food systems where the hydration event is occurring in the mouth. So the applications or the challenges for this aren't unique to chocolate. I've listed meat alternatives, extruded cereal products, protein bars. Those are other food systems where you can have very, very dry fibre-rich systems, either as the native ingredients or whether those fibre ingredients have already been cooked into the product. But whichever way you cut it, you have a very dry fibre-rich system which is undergoing that hydration event in mouth. So I'll end it there. So hopefully that's, in the last sort of 15 minutes, given a sufficient sort of grounding in what chocolate is structurally, why we want to do what we'd like to do with these fibre-rich ingredients for reasons of sustainability, but where we face challenges today. Hopefully within there somewhere, within my ramblings, there's some nuggets of some soft matter relevant thinking, which hopefully this group and those dialed in online have seen something of relevance and interest there. So yeah, thank you for listening, and any questions?
Okay, there will be a question that's come up in a moment. Is there any questions in the audience? Yeah. Is the variability of, this is from Kate Oliver at Innovia. So, is the variability of waste products, particularly less processed ones, something that causes you issues when formulating around them?
Yes, very much so. So the ingredients which do come with these potentially greater sustainability credentials, I mentioned upcycling of apple pomace, that summarises one of the challenges very, very nicely, that they're about as minimally processed as you can get. So in short, yes. The application within chocolate, where we're putting these into dry powders, by and large, that's not how these ingredients are intended to be used. They're normally there for a salad dressing, for example, where you have the opportunity to hydrate them and then have some level of say over how they're functionalised and what they do. So you, to an extent, you can kind of overcome some of that natural variability. Where I want to use them essentially as they're received in bulk to the factory, that natural variability is an issue. So for me, the whole area around what additional processing can a manufacturer such as Mondelez do? We can take in this relatively variable raw material stock. What can we do to either normalise its properties or at least tweak its functionality to bend it to our needs a bit more? So in short, yes, and we'd love some elegant ways to take in these low-cost, lovely, sustainable stocks and move them more into the functionality area that we typically get from more refined ingredients.
Question over here. Question there.
Yeah, thanks very much, Tom. Buckley from York. When is a blob not a blob? I just know that there were a few times in this conference where people have admitted that the cartoons of nice, compact, blob-like things, from crystal aggregates to phase-separated, components aren't actually quite as compact as all that. And in the food industry, there's been over a number of years issue of fat reduction by, well, if we could only paint the fat just on the surface of the droplets, it would taste and look feel just the same, and it would be. Is that still the case? Do you still believe that, or are what looks like droplets with or particles with surface accessibility only something much more complex that's actually more fractal or accessible into the bulk when it comes to these complex foods?
Not the best way to tackle that is. So I think the challenge around continuous phase minimization for sort of factors things such as chocolate, it's still very, very much there. I think certainly for taking chocolate as the example, I think we're rapidly approaching the stage where, whilst I think technically we could achieve some very, very interesting, very low levels of continuous phase, really sail very close to the wind in terms of getting to a fully jammed system. I mean, particle-particle interactions are pretty much dominating as it is. I think there's still a bit of room to manoeuvre there. I think we can still work on those and overcome those and address the rheological challenges. I think we've still got a bit of headroom there. I think but then when you start to consume those products, there's no two ways about it. You can paint the fat as thin as you like and still demonstrate very, very nice flow from a process standpoint. But there isn't much fall in the human mouth. Incredibly sensitive tool. And I think that's often the misstep at times. There can be an over reliance or concentrate too much on the industrial application, getting things flowable, getting the flow rates up, getting depositing speeds higher and higher. But at the end of the day, if we cannot get them to behave in mouth as we want them to, we can churn out as many kilotons of that as a year as we want. If it's not delivering on the consumer expectation, it's wasted time and effort. Now, fortunately, I think given how relatively new and emerging this area of oral processing and kind of manipulating the bolus thing is, I'd like to believe we can kind of break that tension there. So I'd like to think that we can really go to town on the minimisation of the continuous phase and overcome the challenges of kind of particle jamming, but at the same time deploy some quite interesting mechanics around what happens in the mouth, so we're not reliant on having an excess of continuous phase to deliver that sensory experience. Yeah. So in short, yeah, it's still a challenge, but I think it's about breaking those links there, so continuous phase volume shouldn't be the driver of rheology and texture.
Very quick.
Right. Very close to my heart. The question about variability. Cocoa butter and cocoa powder are themselves natural and highly variable materials. And the key is introducing sensors and process and product understanding.
Okay, I think we need to pass on because we're already about 4 minutes. So thank you very much.